All right, question number 6 on the 2024 AP Calculus AB exam. I'm going to work this one out, and I have not looked at the problem yet, so you're going to get to see me read through the problem and feel my way through it in real time. If I make any mistakes, be sure to let me know in the comments. I'm sure you will. Let's see. All right, so we're looking at, it's probably going to be an area volume question. It's a guess off first appearances. We have two functions, fairly clean parabolas shown above. We have an F, a G, we have a region R and a region S. R is the region bounded by the graphs of F and G from 0 to 2. Right, but do not evaluate. Why are we not evaluating that? That's an easy antiderivative. Okay, whatever. Right, but do not evaluate an integral to find that area. This is nice. And because we're not evaluating it, let's not bother writing the actual equations. They called these functions F and G. This is the antiderivative from 0 to 2 of my top curve, which is f of x, minus my bottom curve, which is g of x, dx, and we're done. Wow. Okay, on to B. That was nice. S is the region bounded by the graph of G, the x-axis from 2 to 5. It's the base of a solid. Cross-section perpendicular to the x-axis is a rectangle with height equal to half its base in region R. Find the volume of the solid. Ooh, this time we actually do need to find the volume. And show the work leads to your answer. Okay, so every volume problem we do in AP Calculus can be done by doing the antiderivative of your cross-section area. They tell us, actually, I'm just going to write antiderivative of the area of the cross-section. This will be a dx problem. My cross-section is a rectangle, and so the area is going to be base times height. The base is in the region, which is determined by the function g of x. So g of x is my base. My height, they say, is half. Was it half? The height equal to half its base is half of the base, which would be half of g of x. And so I'll roll all of that into a single antiderivative, and it will be the antiderivative of half of g times g dx. That would be from 2 to 5. And I'm going to write it that way first for the setup because I anticipate you get points for correctly setting up the antiderivative, and that is indeed a good setup. However, we are asked to evaluate this antiderivative, so I'm going to bring that 1/2 out. I'm going to replace g of x with its equation, which is x squared minus 2x. And this is going to be a nice antiderivative, but you have to be able to expand a binomial. And if you can't do that, that's on you. Make sure you FOIL that completely. That will be x to the 4th minus 4x to the cubed plus 2x to the 2th dx. Find the antiderivative. So that's 1/2. I'm going to leave that 1/2 out. The antiderivative is x to the 5th over 5 minus 4x to the 4th over, that'd be x to the 4th plus 2x cubed divided by 3. We'll evaluate that from 2 to 5. And we get 1/2 of, plug in the 5 first, 5 to the 5th over 5 minus 5 to the 4th plus 2 times 5 to the cubed over 3. So I substituted my 5 in for the x's. Now I will subtract and I'll substitute my 2's. That's 2 to the 5th. I think that's 32, but let's not risk it. It might not be today. 2 to the 4th. I believe that's 16, but I don't want to risk it. I'm going to leave it as 2 to the 4th plus 2 times 2 to the cubed, probably 8, but nah, who cares? Close parentheses, close brackets. Watch your parentheses on problems like this. It's very easy to leave parentheses out, which could change the meaning of your answer. I believe that's good. Yeah, I'm not seeing anything else that needs to be done with that. So I like that. This is a pretty nice question so far. Let's see. Why is that group so weird? That was funny. I wanted to shrink this up to give me room for question C. All right, on to C. Let's look at question C. Write but do not evaluate an integral expression that gives the volume of the solid generated when S is rotated around the horizontal line y equals 20. So I'm going to sketch this very quickly. So here's S, and this is at x equals 5. This is x equals 2. That's my region S. that function that is defining the upper boundary is the function of g of x. This point right here is at y equals 15, so y equals 20 is going to be just north of that. Here's my axis of rotation. All rotational problems in AP Calculus are to be solved with disks or washers. If you happen to know shells, I suppose you could, but they're not going to ask you anything that knows shells. And this is indeed a washer. There's empty space between my bounded region and the axis of rotation. The cross sections, your circular cross sections, your washer cross sections will be perpendicular to the x-axis. A washer, we're going to do pi antiderivative of big R squared minus little r squared. And you always draw your radius from the axis of rotation. So I'm going to draw my big R from axis of rotation to my far boundary. So there's big R, little r, axis of rotation to the near boundary. So there's little r. And because we are not measuring back to the axis in both of these, I'm going to do top minus bottom. Big R, my top point is on line y equals 20. My bottom is on the x-axis, which is line y equals 0. So obviously you need to put minus 0. Little r, however, we do need to do top minus bottom. That's going to be 20 minus the function g of x. And I'm just going to roll all of that into an antiderivative. Pi antiderivative of big R, which is 20 squared, minus little r, which is 20 minus g of x. And because we're not actually evaluating this integral, I'm going to leave it in terms of g of x. There's no point in copying the equation down. Squared little r. And limits of integration are 2 to 5. And we are done. That is all 6 questions on the AP Calculus AB exam from the year 2024. If I made any mistakes, make sure to comment down below. And hopefully you enjoyed this.